Okay, so in this video we're going to look at number 5 on the Chapter 8 review, which is we're dealing with a infinite sum. So it's kind of similar to what we were doing before, only I am adding up an infinite number of numbers, so I'm not ever stopping this sum. And I wonder, does this get close to a number, right? The numbers I'm dealing with here are getting smaller, and so as they get smaller, I'm adding less and less every time. So it's possible I could be getting close to a number when I add up all these infinitely many numbers. And so when you add up infinitely many numbers and it does get really close to a number, we say that the sum converges. Okay? And where this is a geometric sequence, it tells us, or a geometric series, that means that you've added up infinitely many terms of a geometric sequence. Okay? We want to know, does this converge and what does it converge to? Okay? So, first of all, we want to figure out some things about these numbers and how they are related in terms of a geometric sequence. So remember, a geometric sequence has that you will, or you times by the same thing every time to get to the next number. Now this one is a little bit hard to see the pattern of what's going on here, but we do know it's geometric because it tells us it is. So every time I go from one term to the next term, I'm going to be timesing by r, right? Whatever that r is, okay? Because it's geometric, but it should have a common ratio. So then what should r be in this particular problem? Well, we know that when I take 900 and I times it by r, I should get negative 720. So then what would r need to be? I can just divide both sides by 900. And this would be negative 0.8, I believe. So we were able to find what that common ratio was just by dividing this term by that term, right? And if we did the same, we did negative 0.8 times negative 720, if we times these two together, I bet you will get 576. Okay? And I just threw it in the calculator, and yes, you do. You get 576. So every time I'm timesing by negative 0.8 to get between these numbers. So that's what r is. Okay? So, to find the sum of this geometric series, first we need to figure out, does it actually converge? And how you tell for a geometric sum here, an infinite geometric sum, is you look at r. Okay? And the absolute value of r needs to be less than 1 to converge. Okay? So, in my case, when I do the absolute value of negative 0.8, that just makes it positive, and that is less than 1. Okay? So, it does converge. Now, what does it converge to? Well, in one of the formulas on your formula sheet is going to be this formula. S is equal to A1 divided by 1 minus R. This is what it converges to when it does converge. Okay, so when the absolute value of R is less than 1. So, we just take r and we plug it into this equation. So in our case, S would be, well, A1 is 900 divided by 1 minus negative 0.8. So we get 900 divided by 1.8, which is 500. Okay, so when we add up all these numbers, it gets really close to 500, and so that would be our answer here. Okay, so hopefully that helps. Again, with infinite sums, ones that don't stop, you use a slightly different formula than the ones that do. You use an SN. When you're just adding up finitely many terms. If you're adding up infinitely many, you have to use, they usually just write a S on our formula sheet. So anyway, hopefully that helps. I will see you in the next video.